Okay, so this is the higher paper one from the set one of practice papers, okay? I'm not going to do the whole paper, I'm just going to do questions 1 to 15, okay? We've talked about this before, but that would be 38 marks worth of things, okay? That would be enough to get you a grade 6. I'll do the rest at another point, okay? But for now, for us, that's all I'm doing, just the first half or so, okay? You'll notice on each question I've written out what the question is, okay? So question 2 would be about nth term, for instance. Just if you want to look any more revision questions, okay, look up the red thing essentially and you'll be okay? So you don't have to watch the whole thing, but I'm going to go through everything, okay? So feel free to skip ahead if you need to, okay? Right, question 1, ordering decimals. Question 2, ordering decimals as well, actually. But this is how we do it. Okay, I'm looking at this one here, the last one, and I can see there's 3 numbers after the decimal point, okay, whereas all the others have either 1 or 2. So I'm going to change the rest so they now have 3 numbers afterwards, okay. This first one, I'm going to write 0 here, okay, and the third one, I'm going to do the same. Okay, but the second one, I'm not going to fill it with zeros because this thing here is telling me it's not zeros after it, it's 3 after it. I'm going to have 2 of them, so I've got 3 numbers after the decimal point for each one, okay? Now, it's just a case of looking at the numbers. So the last 3 numbers there are 310. Last 3 numbers there, 333. Last numbers there, 330. And this one is 301. Okay, so the smallest number on the end is 301, so that is the smallest number there, okay? We'll carry on. Next one, okay, very, very similar. So I'm going to make 3 numbers because that one has 3 numbers afterwards. Okay, this one's going to have a 0, and this one at the front's going to have 2 zeros. This one in the middle needs 2 1s, okay, because that means we've got repeating 1s forever, okay? And then just as I did, I've got 100, 111, 110 and 101. Okay, so the largest number in this case is 111 at the end. They both all start with a 7, so there we go for that. Okay, so that's ordering decimals. Okay, next one, nth term. It's a bit of a strange one, this, and this is one of the few ones where actually the answers really help you because you can almost do a process of elimination on them. Okay, let's do it properly though. Let's look at these numbers. So I've got 40, 35, 30, 25, 20. I know it's going down in 5s, okay. If it was going up in 5s, I'd write 5n, but it's not. It's going down in 5, so I have to write minus 5n. Then the question's always this: how do I get from a minus 5 to a plus 40? Minus 5, add 45 is how you get from minus 5 to a plus 40. Okay, that is my nth term. That is none of the answers above, though. Another way of writing that is if I swap them round, essentially. So I'm going to get 45 plus 45, which is what that is. I'm going to move the other bit there, so minus 5n. So it is this one. Here's how this is quite helpful. These answers here, I know it's minus 5n, and that is the only one with minus 5n in it. All the rest have either 5n or n, so it had to be that one without even working out the 45 part. Okay, let's keep going. Question 3. Okay, question 3 is about standard form, which is quite a big topic, but it's only a 1-mark question. Let's have a look at it. Okay, so which is not a square number? Read that carefully. So I'm going to write all these numbers out as full numbers. Okay, this is in standard form, 4 times 10 to the power 2, and all that 2 is telling me as I start with a 4 and write 2 zeros afterwards. Okay, so let's carry on with that. 4 and then 6 zeros. 1, 2, 3, 4, 5, 6. That's 4 million is what that second one means. 9 followed by 3 zeros, so 9,000. And then 9 followed by 4 zeros. Okay, so that'll be 90,000. What I'm after is which of these can you not square root? Okay, so I'm going to go through them in turn. So the first one I know is 20 squared. So that one I can square root. Okay. Next one, I would be 2,000 squared. You can just sort of play around with these numbers. I know it's going to be 2 because the square root of 4 is 2, and then work out how many zeros you need. That would be 2,000 squared. Next one would be square root of 9, 3. So I know if you square 300, you get 9 with 4 zeros. Okay, so that one I can as well. I'm stuck in that one. I can't square root 9,000. Okay, you'd think it'd be 30 or 300, but it doesn't work if you try those. Okay, here's a clue. Have a look at the powers. I've got 2, 6, 3, and 4. The odd one out there is 3 because it is an odd number. Okay, so essentially you can't square root a power that has an odd power. Okay. That's standard form. Next one, long division. Okay, right. These can become really messy if you do it properly. Essentially, if you have a look at the actual calculation, 6.32 divided by 0.12. Okay. Now here's a trick. You can make life a lot easier for yourself. This only works with dividing if you make it so you haven't got any decimals. So what I'm going to do is I'm going to times that number there by 100, because if I do that, it means the first number, that number 0.12 would just become 12, which is a lot easier to deal with, okay? But if I'm timesing that by 100, I'm also going to times the first number by 100, okay? So instead of 64.32, I've got 6,432, okay? Now this calculation here will give you the same answer as this one, so that's what I'm going to do instead, okay? I don't need to do anything with my answer, that will just be the answer when I do it, okay? Here's a little tip. When you're doing long division, I'm going to write out 12 times table because it just makes life a lot easier. So 12, 24, 36, 48. So just take your time doing this. Make sure you got it right because we're going to be referring back to it in a bit. 72, 84, 96. I'll do for now, okay? And then we're going to set out like the bus stop, okay? So 12s into 6, 4, 3, 2. I'm going to draw my little bus stop thing there, okay? How many 12s go into 6? None. So instead of starting there, I'm going to start with how many 12s go into 64. Okay. How many 12s go into 64? Look down your list. 1, 2, 3, 4, 5 of them. That would take me up to 60, but I've got a remainder 4. How many 12s go into 43? I'm going to go on the other side. I'm going to do a little start. So 1, 2, 3 of them. So I can fit 3 in there. Remainder 36 to 43 is 7. Okay, and then how many 12s go into 72? I want that one over there on the left. Okay, so it's 6. So my answer is 536. Don't add anything else in. Don't put any decimal places in because we changed the sum, which means we get the right answer whatever we do. Okay, so there's a bit of long division. Now we get on to a bit more of the sort of normal questions. Okay, so let's have a look at scattergraphs, and you'll notice, I've done it in green, okay, but whenever you see a scattergraph question, the very first thing I'm going to do is draw a line of best fit, okay? Line of the best fit, make sure it goes right across your graph, and it sort of goes pretty much through the middle of where the dots go. There's not an exact science to it, but it has to be roughly like this, okay? Some people think it has to go through there, but it doesn't, okay? It pretty much most of the time won't go through the what we call the origin, which is there. Now let's have a look. Describe the correlation: strong positive, weak negative, or strong negative, okay? Positive means that the dots are going up, so it's definitely going to be one of these two, okay? And strong positive basically means that the dots are hugging the line really tightly. If it was just generally sort of going up sort of like this, where it's roughly going up from bottom left to top right, that's what you call weak positive, okay? Those dots are roughly going up bottom left to top right, but they're in a really nice sort of rigid line, then it's strong positive, so that's what I want with that, okay? Use the line of best fit to estimate the number of tests needed to pass by a person who has 50 lessons, okay? Now, annoyingly, my ruler isn't working properly on this, okay? So 50 lessons, I'm going to find that along the bottom. I'm going to get rid of this stuff first. 50 lessons is there. And you would do this with a ruler, but like I say, mine's not working. I would draw a line. You can do it dotted if you want, or you can just do a straight one. And then you would go back across your line until you hit the other axis, which is at 4. So I'm going to say, using my line of best fit, then you need to write 4 here. And I've got my working out on the graph, okay? If it said 4.2, just put 4.2. It doesn't say why you can't have that, okay? But we'll just use your line of best fit, whatever it is, okay? Mira says, I can use this trend to predict the number of driving tests needed to pass for any number of driving tests. Comment on her statement. Okay, really, our line of best fit is only valid for the data we have, which only goes up to 65-ish lessons, okay? So if someone had, say, I know it's a bit ridiculous, but if they had 1,000 lessons, I wouldn't be able to necessarily use this graph because this line goes up here. After here, it could do anything. It could go like that, it could go down, it could be wobbly or something. We don't know, okay? So basically, here's what I'm going to write. I can only use this graph. Oops. To predict within the range of data given. Okay, so it's only useful, this graph, to the points I have, really. It's not, I don't know what happens in the future, and this graph's not going to help me predict that, okay? Something like that. Anyway, 1 mark, there you go, okay? So the next one is ordering fractions. There's a few ways to do this, okay? There's an alternate way to do it, which would be just to change these 3 things into percentages, which is fine. 5/8 is quite tricky. I'll come to that one later if you're going to do that. This is how I would do this, though. I would look at the bottom 3 numbers. There's 3 denominators, which are 5, 8, and 2. And I'm thinking what number is in the 5 times table, the 8 times table, and the 2 times table, okay? And the first number I get to is 40, if you were to write out all those times tables. So I'm going to write all of these things as something over 40. So I'm going to start with the easy one. A half is something over 40. Well, it must just be 20 over 40. Yeah, because 20 over 40 is a half. Okay, so that's the easy one. Let's have a look at the harder ones. Okay, so the first one, what do I times 5 by to get 40? I times it by 8. Okay, so I need to times top and bottom by 8. So that would be 16 over 40. And the second one, what do I times 8 by to get 40? I would times it by 5. And if I times the top as well, it'll stay as 5/8, but it's equal to 25 over 40. So, which is closer to 20/40ths? Is it this number here or this number here? Well, that is 4 away, because it's 16 from 20, and this is 5 away. So, there you go, that's your answer. I know this one is closer. 16/40ths is closer, but they're pretty similar, those 2 numbers, okay? So that would be 2/5 is what my answer is, because it's slightly closer, okay? If you did want to go down the percent route, then I'm going to write them at the top. You sort of need to make the bottom number 100 if you're going to do it, but the first one would be 40%. The second one would be 62.5%, okay? 1/8 is half of a quarter, and it's 5 of them. You end up with 62.5%, and this one is 50%. Okay, so again, you can see that one is closer to that one. It's only 10% away. That's how you would do that one. Okay, it's quite hard without a calculator, that though. Okay, I think my way is a bit easier. Let's carry on going. Ordering fractions. Next, we have algebraic expressions. Okay, this is not a particularly nice question. Let's just have a look at what we've got. Okay, we have in this picture 1, 2, 3, 4, 5 different rectangles. Okay, it's like almost like a net of a box without a top is essentially what we've got. And here we get this little expression, so it means A times D, that's what AD means, plus C times D. So what I'm after is a box that has one side A and one side D. So all the middle boxes have one side that is A, because A across the top. And then I want one that is also D. Well, the only rectangle that is A across the top and D across the side, length and width, would be this middle one. So that's what I want for A times D, or AD. So that's that one dealt with. And I also need a C and D, which is a bit easier because you can see where the letters are. There's a C there. So I'm going to colour in the bits that CD as well. That's all this question wants. It just wants you to shade in 2 rectangles. And 2 rectangles are just length times width. That's how you work out the area, okay? This one is similar. They've just made it slightly harder. Remember, these are 1 mark, so it's not like asking you to do loads. This one, I'm going to times these 2 things. This is called expanding a bracket to get AD, or I'm going to write A times D because that's what I'm doing. Plus 2 times C times D. Okay, this is really similar to that one above, because I know that AD I'll do it in a highlighter. Okay, so AD is the middle, again, because it's what we had before. And I want 2 lots of C times D. Well, there's C times D there, same as the last one, but that's another C times D. Okay, so what it really wants for me in that question is just to shade in that whole middle section. Okay, there's only actually one answer for that. If I go back to the first one, I could have had the left-hand side for that CD. I could have had either one. Okay, so I'll pick the right-hand side one. Okay, write an expression for the area of the whole shape. Okay, I'm going to write inside these rectangles what they are in terms of algebra. So the area of the top is an A and a B, so I'll get A times B or AB. And the bottom is also AB, because it's still A across the top and B on the sides. Now we've already worked out these, that's CD and that's CD. And the middle's the harder bit, it's A across the top and it's D on the side, so that's AD. Right, what is an expression, I'll show you what an expression is in a second, for the area of the whole shape. Easiest way to write that is this. I've got an AB plus, I'm just writing the middle ones first, plus an AD plus an AB plus a CD plus a CD. That is fine. That will get you full marks if you just write what I've written there, okay? That's okay. I can do that. It doesn't look quite right to me because I can do what we call collecting like terms, okay? I've got AB and I've got one there and I've got another one there. So I've got 2 lots of AB. Okay, I've got an AD in the middle, and then I've got, if you look here, a CD and a CD, so I've got 2 lots of CD, okay. Those 2 things are exactly equivalent, okay, I can have either one, it doesn't matter, okay. It's probably more work to do the bottom bit, but either answer's fine, they mean the same thing, okay. Question 8, I'm going to skip for now because we have not done it yet, okay, but I will get back to that one at a later date. It's really hard for what it is, and it's basically a case of remembering what cos 30 is. That's essentially what we're going to do, but we're just going to leave that for now. I'll come back to it another time, okay. Question 9 is a really strange one, and if you got this question, you'd be really happy in the test, okay. I'll show you why. It's just reading this graph. So it says there's a 1,000-meter race, so I know they finish when they get to 1,000 meters. And then the first question is, who won the race? Well, who's the first person to finish the race? This person here, because these 2 finished at the same time later on, okay? So the winner, if I follow that back, is Ben. And that's all I need to write. I need to write Ben, and a reason, because he finished quickest, or he finished earliest or something. Finished in the least time, something like that, okay? There we go. Straightforward. Part B, describe the race. Again, 4 marks. If you got this question, you'd be laughing because all it wants from us is 4 things that happen in the race. The only weird thing in the mark scheme is that it wants, it needs you to mention at some point at least all of the races, okay? But I'm literally going to write 4 bullet points, okay? So what happens, just looking at the graph, well, if you look at Alan, his line is the steepest at the start, so I'm going to write 1 point is Alan started quickest. Okay, and you just need to find any 4 things that happened, okay. If we're talking about quickness, if you look at Ben's line and Carl's line, okay, they are parallel, these 2 lines here, so that means that they're running at the same speed. So Ben and Carl finished at the same speed. At the same speed. It's a strange one, this, like I say, I'm just looking for any 4 points. It doesn't really matter. I don't really have to describe the race even, okay. What else is in any way interesting from this graph? These 2 things finish at the same time. So know that Carl and Alan finished together, okay? Carl and Alan together. If this was me in the actual test, I'd probably say what time they did finish, but we'll carry on for now. Okay, and what else happened that's of any note at all, really? I can see this, that Alan stopped for a bit, okay, because distance doesn't change for a bit, so I'm just going to write that Alan stopped for a bit. So basically Alan stopped, or I'm going to write Alan rested after 3 minutes. I could go on. I'm literally just describing anything I can tell you from that graph. Okay, so like I say, I could probably write about 20 things if I wanted to, but I'm just going to write 4, and I'm going to write them in bullet points because it's nice and easy. Let's move on. This is a really important question that you look at this at some point. You haven't done it with me yet. We'll do it soon. Okay, these are called simultaneous equations. I need to solve that equation and that equation at the same time. Okay. If you look at the bottom one, I need 2 numbers that add up to 6. So you could say, well, x is 5 and y is 1. But if you did, then it's probably not going to make the top one work. If I put x is 5 and y is 1 into the top one, it wouldn't work. Okay, so there is only one answer for these, and I'll show you how these work. I'm going to start by writing the top one as is. Okay, so I'm going to write 2x plus 3y equals 15.5. Now, this is how you solve simultaneous equations. I want either this x to be the same as this thing, or I want this y to be the same as this thing. And I'm going to make this x here equal to 2x because I've got 2x on the top. Okay, and the only way you can make things the same with equations is to times them all by something. So what I'm going to do is double that whole bottom line because I want that x at the front to become 2x at the front. Okay, so this, I'll use a little blue thing there. This line, when I double it, I'm going to write it here underneath the other one, which I've just written normally. Okay, if I double that bottom row, I get 2x plus 2y equals 12. Okay, that is equivalent to the thing above it. I've just doubled everything, but it still makes it means it's like in the same proportion. It means it's the same. Okay, and here's what you do. If you have x's on the top and bottom, I'm going to take away the whole bottom line from the whole top line. So 2x take away 2x is nothing. 3y take away 2y is y. Okay, I'm just going to write plus here. I didn't really need to write 0 at the front. Okay, equals 15.5 take away 12, which is 3.5. So this equation is just telling me that y equals 3.5. So I'm going to write this straight away in the answer bit. Y equals 3.5. And then final thing, if I look at that second equation, I'm just going to highlight it in yellow just because I'm going to go back over it. But I know that I said at the start that x add y had to equal 6. So this thing here add this thing here, the x and the y have to equal 6. So 6 take away 3.5 is 2.5, and that is my answer. I'm finished. Okay, really handy if you can get a hold of them. Okay, 3 marks, quite nice, and they'll be quite similar in the actual test when you come to them. Okay, they're called simultaneous equations. And then question 11 is quite a tricky averages one, but it is worth 3 marks, so we'll have a look. 5 integers, whole numbers. Mode, most common, median is the middle when they're in order, and mean is 10. What's the greatest possible range? There's a lot of info going on in this one, but I'm going to start like this. I've got 5 numbers, so I'm just going to write out 5 spaces. 1, 2, 3, 4, 5. I'm going to fill in what I know. Well, the easiest one to do is the median is 8, so I know that's an 8. I know the mode is 6, so I know there's at least 2 6s. There has to be 2 6s because I have to write these numbers in order as well. So I know that has to be a 6 and that has to be a 6. Okay, because now I've got more 6s than anything else. What's important that these next 2 numbers can't be the same because otherwise the mode wouldn't be 6, and none of them can be 8 because then the mode still wouldn't be 6. Okay, and then we look at what other info we've got. This is the tricky bit here. So I've dealt with that and I've dealt with that. So I'm just looking at what else we've got. The mean is 10. How do you work out a mean? You add them all up to get some number. Then you divide it by, in this case, 5, because you divide it by how many numbers you've got, and that has to equal 10. Well, if I look at that equation I've written out, something divided by 5 equals 10. That means all of these numbers have to add up to 50. Okay? I know all these numbers have to add up to 50 because 50 divided by 5 is 10. So let's look at what we've got so far. What's 6 add 8 is 20. So these 2 numbers here have to add up to 30. Okay, because 50 take away 20 is 30. That's what I'm left with. I'm not allowed to use an 8, okay? So, what is the biggest possible range? So let's just think of what numbers we could have here. I could have that as a 9. That's the next number I am allowed, so I'm not allowed it to be an 8. And if that was a 9, this would have to be a 21. If I did that, okay? Let's have a look at the range. The range is biggest takeaway smallest equals 21 minus 6, which is 15. Basically, can we beat that? Okay, so can we beat 15? Let's try it, okay? I'm going to write it down here, but if I had 6, 6, 8, let's say that was slightly bigger, so the next number was 10. Remember, these two make 30, so that would have to be 20. What's the range now? For this one, the range is equal to 20 minus 6, which is 14. What is the greatest possible range? It's looking like it's going to be this, because it looks like if I make this number any bigger, it's going to give me a smaller range. So the answer is 15. That is the biggest possible range. Okay. Quite a hard one that, but just start by writing in some numbers and think about what you know. The real hard bit to get your head around is this. If the mean is 10, then all the numbers must add up to 50, because 50 divided by 5 is 10. Okay, that's the really hard bit, all of this bit over here. Okay. Number 12, expanding brackets, collected like terms. I saw a lot of people when they had a look at this and they basically just gave up because it looks a lot worse than it actually is. Okay. There's some basics of algebra that we need to have a look at here. And the first one is, well, the first bit, the main bit is expanding a bracket. So what I do is I times everything in this bracket by 2. 2 times 7x is 14x. And 2 times plus 4 is plus 8. Okay? Look at the next bit. Minus 4 times x is minus 4x. And be really careful with this next bit. Minus is still minus 4 outside. That isn't a 4 outside, it's a minus 4. Minus 4 times plus 6 is minus 24. And then I'm just going to shove that plus 1 on the end as it was, okay? Now we need to do what we call collecting like terms, which is why I've written that bit there, okay? I've got 14x. I have to, if I'm doing highlighting, I need to highlight the symbol in front, so I've got a minus 4x as well, okay? What is 14x take away 4x? It's 10x. I'm going to shift colours, so plus 8, minus 24, and then add 1. That's quite hard to do. 8 take away 24 is minus 16. And if you add 1, you get minus 15. So that's what goes here, okay? I've got most of my marks here, but I haven't quite finished. It wants it with a bracket in, confusingly, okay? I'm going to do what we call factorising of this last bit, okay? So I've got 10x minus 15. I need to factorise that. What is a number that goes into 10 and 15? 5. What do I times 5 by to get 10x? I would times it by 2x. I'm going to get rid of that dot because it's confusing. And then what do I times 5 by again to get 50, or in this case minus 15? It would be minus 3. And we have finished. Have a look at my answer. Have a look at my answer and the bit of form it wanted in. It's something, in my case 5, times something x, in this case 2, plus c, but it's really a minus. It's minus 3, but that's okay. You're allowed that, okay? So that's how we do that. Not that bad. You should definitely get method marks. You should definitely be able to get to this stage here. And you should probably be able to get that stage here. And if you can do that, just factorise it, okay? So that's pretty standard stuff, okay? Question 12. We haven't got much more to do. Question 13. Here's a map of France. Let's do scale drawings. Just all I need is a key, really, okay? 1 centimetre is worth 80 kilometres. Estimate the time it takes to drive to Paris. The road is straight and average speed of that. Okay, so first off, I've already done this, but on the one I gave to you, which was actually shrunk down, but we'll stick with your one, the distance between Paris and Marseille is 5.5 centimetres, okay? And I know that every 1 centimetre is equal to 80 kilometres. So my first thing I need to do is 5.5 times 80, okay? So I'm going to use the grid method, and I'm going to do it slightly differently. I'm going to do 55 times by 80. Okay, I'm going to use grid method to times those two things. Use whatever method you want, but it's easier if you don't use decimals and then you put it back in later. I'll explain in a bit, okay? 8 times 5 is 40, but I've got 2 zeros. If I can squeeze it in, so that's 4,000. 80 times 5 is 400. So this one I'm doing 5.5 times 80, which is equal to, so I get this number 4,400. Okay, but it's not really, because my first sum is really 5 times, bit up more than 5 times 80. 5 times 80 is 400, so the decimal point is going to have to go in there. Okay, so I know it's actually 440 kilometers. That's what I get. Okay, so that's what I do if I do 5.5 times 80. I get 440, so 440 kilometers. Okay. Estimate the time, so it all comes back to this. Speed is d over t. Can you remember what I said, dancing on tables? Okay, so I'm after the time, which is distance divided by speed. So the time is 440 divided by the speed, which is 100. 440 divided by 100 is 4.4. We don't even have to mess around with minutes or anything. It's quite nice, this question. My answer is just 4.4 hours, okay? If I did want to change it to minutes, it's probably on a calculator paper. You need to do 0.4 times 60, and that'll tell you how many minutes, okay? But otherwise, we're fine, 4.4. Comments on how each assumption affects the accuracy of your estimate. What that's getting at is this. It says assuming, okay? The road is straight. What are the chances that there is a perfectly straight road from Paris to Marseille? I would say pretty much 0. Okay, in reality, to get from Paris to Marseille, you probably have to do some weird journey, like, I don't know, you might even have to go to Lyon and back or something. Whatever it is, that line is going to be longer than the straight line, okay? So assumption 1 is going to say something like distance probably the longer as line, as not line, we know what we're talking about, road won't be straight. Okay, so assuming it was straight, it's actually further than that, so that means we probably underestimated real answer, okay? Real time or something, okay? So it's going to take longer because it's further, that's all I'm saying with that, okay? And then the second one, an average speed of 100 kilometers an hour, so we took that assumption at face value, but if we drive slower, say, all right today, on average, if you drive slower, the time will be bigger, yeah? Time will be more, time will be larger, something like that, okay? If you're driving slower, it's going to take you longer to get somewhere, nice and straightforward, okay? And question 14, which is what I said was all I was going to do for this, okay? There are some that are fine, but I'll do them in another video, okay? That's probably enough for now. Question 14, the pilot of an aircraft wants to fly from A to D. The aircraft flies from A to E, 1 degree off course. The distance B to C is 1 mile, work out the distance D to E. This is exactly what we've been doing last week, my class, okay? It's similar triangles. And what you have is this little one here, which is this one. I know that's not very straight, but there we go. I've got that one there. And then I'm also going to draw, what if this thing was just one massive triangle, okay? So I'm going to just draw a larger triangle here, and this is the whole thing. So this one is ADE, and the one on the left is ABC, okay? I know they're not straight, sorry, okay? But anyway, I'm going to label it up. That is 1 degree, and I know this is 60 miles. The big triangle, that is still 1 degree. So I know they're similar because they're both right angle, and that's 1 degree. So I know they're the same. How far is it from A to D? Well, it's the whole way across. So it's not 150, it's actually 210. Okay, I know that is 1 mile as well. And it's asking me how long that is. So what do I times what do I times 60 by to get 210, which is actually harder than it sounds. Let's count up in 60s, 60, 120, and then 180, and then 240. Now 110 is bang in the middle of these, okay, so it's 1, 2, 3, and it's halfway in the middle of that, so it's actually 3.5. So my scale factor equals 3.5, because if I times that by 3.5, I get that. So I need to times 1 by 3.5 to get that, okay? 1 times 3.5 is 3.5. Okay, and we're pretty much done. I've drawn on a green line between C and D because it wouldn't let me do it before. How far should the aircraft have turned? So imagine he's here, okay? If he turns 1 degree, I'll take him back to the horizontal because he sort of started on the horizontal, then he went 1 degree that way, so it'd be back on the horizontal. Is this angle here bigger than 1 degree or not? Okay, it will be slightly less because it's not quite an isosceles triangle. It's quite a hard question this to get your head around, okay, but it's not an isosceles triangle that, because this length's slightly bigger than this one, okay. So he's going to turn 1 degree back to horizontal, then a little bit less than 1 degree to get back to D, so it's going to be somewhere between 1 and 2 is how we'll do our last one, okay. Not a very nice one. The one above it is a lot more sort of practical, okay, but I'm going to leave that for there. That would be 38 marks, I think, so that would be enough for grade 6 if you stop there, okay. I'm going to put more of those videos up at a later date, but that should be enough to be getting on with for now, okay. Thank you.